Hi everybody, today we're going to have a look at slope of a line and see how that fits together with the rest of our coordinate geometry understanding. So, to start with, constant versus difference is directly related to the slope of a line. So here we can see that with table 1 it's increasing by 0.5 each time. It has a constant first difference. It's going to make a line. Table 2 is increasing by 1. It has a constant first difference. This is the first difference here. It's going to form a line. Table 3 has a constant first difference. It's increasing by 2 each time. It's going to form a line. So let's have a look at table 1 as a graph. So if we graph this as a set of coordinates, 1, 0.5, 2, 1, 3, 1.5, we're going to get this line here. And it had a first difference of a half. Table 2 increased by 1, and it had a first difference of 1. And table 3, this one here, had a larger first difference, and it's this green line here. And as we can see, the bigger the first difference, the greater the slope. This is the steepest, this is the least steep. Now in maths we try and be precise, so now rather than saying steep and less steep, we can say it has a gradient of 2, or a gradient of 1, or a gradient of half. And the word gradient and this number, which is related to the gradient, describes slope. Now, there are a few lines that act a little bit differently though. This isn't one of them, but it's a bit hard to think about. So if we have a horizontal line, it has a gradient of 0. As x increases, y does not increase. And you can see here that would be 1, 2, 2, 2, 3, 2, 4, 2, 5, 2. As x increases, y does nothing, therefore we get a horizontal line. And that's true for all horizontal lines. They'll always have a first difference of 0. But a vertical line's a little bit different. We can't represent a vertical line inside a difference table because there are no values for anything but x equals 2. So if we had x equals 2, put 1 here, there's no value on the line, it would be undefined, 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 undefined. So what we have to do is just use a table of values, and we can say when x is 2, y is 1. When x is 2, y is also 2. When x is 2, y is 3. And that's what this table here is representing. And we say the gradient in this case is undefined because we can't define the gradient in terms of changing x values. Now, if we get a negative first difference, so if the values are going down, so from 3 to 2.5 has gone down by half, from 2.5 to 2 has gone down by half, so on and so forth, it does something different to the graph. So here's that line here, table 6, and we can see that it's still got a shallow gradient or slope as per as per gradient equals 0.5, but this time it's going downhill instead of uphill. It's going down instead of up. And as the magnitude of the gradient increases, ignoring the sign, you can see that for gradient equals 1 or a gradient equals -1, it's the same slope or the same angle as gradient equals 1, but in the opposite direction. It's going downhill instead. And the same for gradient equals -2. It's going down by 2 each time for every one that goes across. So there you go. There's a bit of a connection between tables, graphs, first differences, and slope. And I hope that makes your understanding a little bit better, and I'll see you in the next one. Thanks everybody.